Welcome to Embedded Edge with Nitin, a podcast that brings to life the stories behind today's embedded systems, technologies, and products. It's the show where you'll hear from both engineers and executives on some of the most topical news and most pressing challenges in the world of embedded system design. Here's your host, Nitin Dahad.
Today we're going to be talking about redefining touch HMI to optimize form factor in some smart glasses. And my guest to talk about that today is Viveesh Bharathan, who's the Director of Product Marketing at Infineon Technologies. And his focus is very much on touch HMI, which is actually quite an important part of smart glasses. Viveesh, hello, how are you?
Hi, I'm doing great. Thank you for having me here, Nitin. It's my pleasure.
Yes, I know. So we'll talk a little bit about some of the trends in HMI, but just tell me a little bit about your role first, and then, we'll go into that.
Yeah, so I'm based in California, responsible for Piece-Stock Multisense MCU segment, and I'm leading the marketing organization for Piece-Stock Multisense MCUs, predominantly focusing on the HMI, touch HMI solutions.
Okay, very good, very good. Well, that's good. So you have quite a lot of background in that as well, from what I see from your profile and your history. So, Viveesh, let's talk a little bit about some of the trends in HMI. What do you see the market adopting, and what are they looking for to optimize in their products? And I guess, the title of the podcast will say a lot about it, which is form factor. But just let's hear more from you.
Yeah. So if you take a step back and look at the overall what's happening in the touch HMI space in the overall market, I think I see mainly three trends. There is a matured market for the buttons and sliders and wheels, in this everyday products, right? Or the everyday product that you use, such as home appliances, consumer products. Here we see optimization of overall system level cost, utilizing the capability from the touch controller to maybe remove the gaskets and bring a hover touch or things like that. Overall optimize the system cost. Not really looking for the most cheapest solution out there in the market, like the most cheapest chip out there in the market, because if you go down that path, then you're not meeting performance, you're affecting the reliability and so on. But I think the customers are looking at optimizing the overall system cost by innovative ideas. The second trend that I see is on the emerging applications such as wearable, smart glasses, a big trend that we see, right? And there are particular challenges in adopting the HMI or touch HMI in those products, such as rejecting the wet hair, water droplets, and things like that. Power is a big deal because these are operating on a very tiny battery. Everybody wants a smart glass to be, small and sleek as the regular glasses. So form factor plays a very important role. And then the touch performance, signal to noise ratio, to provide a very smooth and sleek interface, gesture capability, etc. I think there a lot of performance enhancements are needed. So this is what is happening in the second trend. See, if you look into the robotics and into the future, the touch HMI is being used in the robotic hands for detecting the objects and type of objects, right? Sometimes when you pick up a glass versus when you pick up a metal piece, you need to apply different types of pressure to lift these things, right, in the robotic hand. So, and I think this kind of innovative sensing is being utilized on the fingertips of robotic hands, looking into the future. It's more on the innovation and advanced concept. I don't think that anybody has completely, sorted that portion. Of course, there are various different technologies out there competing on that space. Some are expensive, some are, very promising. So, I think our solution we see, we are also working with some of our lead customers in that space. So these are top three trends, I would say.
One of those areas, by the way, when we talk about touch or when we talk about HMI, I think you mentioned hover touch. So it's not just touch, but it's gesture control as well, or when you say hover touch nearby, isn't it? Is that right?
So I can explain what hover touch is, and this is one of our innovation that we introduced last year. So if you see a traditional HMI, be it on a remote control, be it on a washing machine, or be it on a cooktop, right? Usually, in many cases, the touch HMI PCB needs to be attached to the plastic or the surface of the product,
Yeah.
and this is how it is everywhere. In certain cases, you may not be able to do that. For example, remote control. You need some kind of plastic backing to maintain the mechanical rigidity of the remote.
Yeah.
Otherwise, it's going to break. So what that means is that the PCB cannot be attached. There is an air gap between the touch surface and the PCB.
Okay.
Same is true for the cooktops, because the cooktop glass surface gets heated up very quickly.
That's right.
Because it's a cooking equipment. And if you attach the PCB to the glass, it cannot be reliably attached, because over the time it will peel off and fall apart, right? So there is a gap between the PCB and the glass surface itself. So you can find the various different applications, much more. It's common than what we may imagine or what we may think. It's very commonly found that the air gap between the touch surface and the PCB.
Interesting.
This is a very, a negative. This creates a very negative impact on the touch performance. And what our customers or the product designers do, they fill that gap with springs or gaskets or some kind of conductive material. So thereby, they're extending the sensor from the PCB using an additional material that is touching the plastic panel. So if it is spring, depending upon the temperature, whether it compresses or expands, the spring handles it and makes sure that it stays in touch with the touch surface, right? So thereby, you can actually get the reliable, required touch performance. The downside of this, the downside of this is that each of those buttons need a spring or a gasket, which adds the cost, right? So if you think about a dishwasher that has a 12 button, you need 12 springs, and think about that, right? It might end up being more expensive than your touch chip itself, right? And now I think that we introduced our 5th generation sensing technology, with a 10x lower power and 10x higher SNR. With this, improvement in the signal-to-noise ratio, we can even sense a much more finite signal. Therefore, we can remove that spring completely, maintain the air gap, and still detect the user touch even with that air gap. So what that does is that it provides exactly the same functionality from the end product perspective, but it helps you remove the springs, thereby cut down a significant portion of your cost from your BOM. Or from your So and I think we see that a fast and rapid adoption of this, because everybody loves the idea of optimizing the cost and increasing your profit margin.
Yeah. I mean, when you're talking about wearables, when you're talking about consumer appliances, it's always about that margin and the cost. So that's quite interesting. But can I just make sure I clarify for our listeners as well? So hover touch isn't the same as gesture control, but it's a form which you've sort of perfected there. Is that right?
That's correct. Yes, it's not a gesture. It is the hover here means that you're able to maintain the air gap between the PCB and the touch surface inside the product.
Okay. Now, and then the other, obviously, in your trends, you talked about smart glasses, and I was sort of looking at various data on smart glasses, and I think various players have said in 2025 there were 5.1 million sales of smart glasses or AI-enabled glasses, and I think that's key in all of this. But there's Omdia has done a very good report, and I think they talk about lighter smart glasses with AI and micro displays are shaping the next wearable device trend, and obviously that leads into the discussion we're going to look at, which is what are the challenges customers face, and it's kind of form factor, but it's shrinking, its responsiveness, its ability to reject things. Should we just talk a little bit about some of the things that you're seeing with those smart glasses and what they're looking to optimize, and how do they optimize the form factor?
Yeah, so first of all, very happy to talk about the smart glasses, because I think we have been involved with a lot of leading players in the space in the last few years. And some of our product definition started 4 years ago with some of the key industry players in the space, enabling a great level of touch HMI on this product. Having said that, I've seen various different types of product. Some are focused more on the audio and audio-related capability, more lightweight. And some of the products are more display-driven. I think the display-driven products are becoming more popular, or that is the trend that we see. And I think I expect an exponential growth in the next 3-year window in the smart glasses, because I think the projections that it changes by week and month. So it's a very exciting time in this space. Also, I think I'm expecting that we will see a lot more smart glasses this year in the market, and I think you will find it very difficult to find a smart glass that does not have an Infineon touch, touch sensing on those glasses. That's the level of adoption that we are seeing, and the collaboration that we are having with key industry players here. So now, having said that, with respect to touch, I think the challenge, there are various, right? Power, I think we see as a great challenge, because it works on a very small battery. And the thing about the touch HMI, you can, when you're not wearing the glass, sitting on a table or things like that, you can actually turn off the display, you can turn off the cameras and things like that, right? But the user interface, the touch user interface, it needs to be always turned on, because you never know when a customer picks up and touches on it to wake up the product and things like that. So even though relatively the touch consumes relatively lesser power, the fact that it is always on makes it important to optimize the overall power.
Right.
And so our response to this was 2 years ago we developed a solution called autonomous always on sensing, where the chip can remain in the deep sleep state, consuming a couple of microns of current, but yet you can do a full scanning of the entire touchpad or the touch surface, touch interface, and provide that the gesture capability in extremely lower power consumption. And we see that majority of the customers value this feature or the power optimization, but this will continue to be a growing a requirement, I think, from the wearable space because of the small battery.
Yeah.
Like I said, I think if you see the glasses today, the frame or the bezels are usually a little thicker or wider, much wider than actually a traditional sunglass or a regular glass, right?
Yeah.
This is to pack the electronics. So everybody is looking at ways to integrate things, right? So one way to look at, and I think they're making a great level of progress there. The touch interface, right, it has its own challenges, right? If you want to provide a very nice gesture user interface, you cannot reduce your size of the finger, right? We are all born with a particular size. So, and as the more and more they shrink the size, the sensor or electrodes, actually, the size also shrinks. And that makes it very difficult, to sense a touch user interface signal and yet provide a great level of gesture, and also make sure that it doesn't false trigger, from spurious or unwanted scenarios. So optimizing the form factor, I see in two ways. One, I think the overall integration from the system perspective, but then even when they are doing it, what happens to the HMI, right? HMI needs a certain amount of space, or you need a very high performing touch controller that can, work with a very small size of the touch surface. So I think we are making the right progress in the right direction. And I think you will see some of the glasses have a very, very thin frames or the bezels in the later this year.
At CES 2026, I saw a lot of the smart glasses, and not just from the usual the big players that we know, it's like Meta and all that, but I think a lot of Chinese players as well. And the weekend before recording this podcast, I actually went in and tried one of the big brands, Meta. And it was quite interesting. Two observations. One is getting used to that touch control to get the volume up and down, for example, on the voice, and also for recording. So I think that is so. As you said, you have to get it right. You have to get that exactly right and still usable by a human finger. But the other thing, which was quite surprising, and you talked about power, is when I was talking to them and I said, look, what about putting my lenses, like my prescription lenses in? And they said, well, you probably want to keep your existing ones, because the charge, it will only go for about 8 hours before you have to recharge it. So I thought, it's not something you're wearing all the time yet. It's something you use just while it's got its charge, and then you have to recharge it. So I think power is going to be very important, because people will want more use of it. Any comments on that?
Yeah, so definitely. So I think you've seen the one type of glass that provides the certain functionality, right? But I think if you look at the China, I've also seen some of the big players building prescription glasses that can last longer on the battery life, right?
Yeah.
And targeted for people who already using the glasses with certain level of power, right? So that's where the power comes in important, right? That it's not an 8-hour charging thing. It needs to be weeks or months, right?
Correct.
So and I think I think you may not see all the AI capability in the starting, right, in those kind of product. But the HMI is an important, whether it's an AI display driven or audio driven, you need the HMI. And that's why the power, optimizing the power on the HMI is super critical for enabling the spectrum of the use cases or a spectrum of smart glass products, not just one display driven product, if that makes sense.
Yeah. But I mean, the reason you're here is we want to talk a little bit about Infineon. How is Infineon Technologies addressing this market?
Like I said, we are addressing the smart glasses with several technologies. And personally, I am responsible for piece of multi-sense. As the name says, it is capable of doing multiple different sensing technologies in a single chip, all related is a smart glass. And we are actually doubling down on improving the power performance, SNR performance, optimize the form factor, and also reject the wet hair, wet finger or water droplets and things like that, and making it much more reliable. So we have a kick-ass solution here on HMI side of things. And one of my colleagues actually deals with SOC Edge microcontroller, class of microcontroller, enabling the edge capabilities, audio and vision-driven edge capabilities or AI ML capabilities at an extremely lower power. So that would be another solution or MC solution that, from my product line, addressing the smart glasses, enabling the vision and audio capability, local processing, and faster response, and so on and so forth. Infineon has, like 7,000 components, I think, or products. So it's, I think, mics, for example, we are one of the best in the market, right? So I see that the mic ML driven MCUs and touch HMI driven MCUs are top 3 players in this space, at least. Right. That's where we are seeing a lot more adoption, in my view.
Interesting. I think one of the videos I saw from the Infineon website back from October Tech 2025 was a demo on, it talked about rejecting water, wet rejection, just how you dipped it in the water, it doesn't activate, but then you put your finger on it and then it does activate. So I think that's actually quite a key feature as well, isn't it?
Exactly. So I think the rejection of water has been there for some time in the past with the shield electrode and all that. In the home appliance cooktop products, I think they were applicable. The thing that about a smart glass, like I said, when the form factor becomes smaller and smaller, those the technologies and the methodologies that we used in the past are no longer relevant. It cannot be used. And that's why we came with a state-of-the-art ground-up concept, where you don't need a shield electrode, you don't need additional sensor electrodes, etc. But you can use the same existing electrode, yet differentiate between a water droplet and a wet hair and a finger. I see that nobody has a solution in the market. Our solution is also completely not released to the market yet. We are working with a very specific lead customer. And I think I expect to see sometime in later 2026 this new technology coming into market. The good thing about this is that this new wet rejection algorithm or the methodology will be enabled on the existing product itself, so that customers can take advantage of right away.
Okay. Well, Viveesh, it's been fascinating to talk to you. But let's summarize. So how can the market redefine and optimize form factor in smart glasses? And what's the importance of the touch sensor in this?
So the touch sensor, like I said, when we optimize in the form factor for smart glasses, we can always optimize the BOM components inside, but I think the area available for touch sensor is going to be crucial. In order for you to minimize the touch sensor area, you do need a high-performing touch controller, such as Infineon's piece of multi-sense that offers 10x better SNR compared to the traditional solutions. So that would be one way to optimize the form factor. When you optimize the form factor that way, then wet rejection and those type of things also comes into picture, because it makes it more complex and challenging to provide a very reliable performance. And that's where Infineon solutions on new wet rejection algorithm or methodology can help maintain the same type of reliability on the touch interface. So on overall, I think the what I hear from the customers in the space, both in the US and the China, the touch interface is going to be a crucial or important interface on these glasses, regardless whether that has an audio or video interfaces on the glasses. That will be one of the primary ways that the customers will or the users will interact with the product.
Well, Viveesh Bharathan, been wonderful talking to you about Touch HMI for smart glasses. Thank you for joining me on this edition of Embedded Edge, and we'll talk to you again soon.
Thank you, Nitin. It's been my pleasure talking to you.